so overlooked that the most consequential contribution the Browning high power made to how pistols are built and carried and trusted across the last 9 decades has been absorbed so completely into the baseline assumption of pistol design that the industry it created does not feel obligated to acknowledge it. In 1935, when Dieudonné Saive completed the design that John Browning had died before finishing, the standard capacity of a service pistol was 7 or 8 rounds. The high power held 13, not through a larger grip but through a staggered double-column magazine, 2 rows of cartridges offset against each other that Saive engineered into a frame slim enough that the pistol could be carried concealed by the Florida invasions. Intelligence agents, special operations personnel, and plainclothes officers who needed a sidearm that did not announce itself. That specific combination, high capacity, locked breech reliability, concealable dimensions, had never been achieved in a production pistol before 1935. It has been the baseline specification of every serious service pistol designed since. The high power is so overlooked not because it was a minor weapon, but because its achievement was so completely adopted by everything that followed it that the achievement itself became invisible. The story begins not with a pistol, but with a magazine, and with a specific institutional requirement that nobody had successfully answered for over 2 decades. Since the turn of the 20th century, the French military had been looking for a semi-automatic pistol that could hold 15 rounds of ammunition for its new service sidearm. The requirement was not arbitrary. French tactical doctrine following the First World War emphasized the individual soldier's ability to sustain fire in the close-quarters urban and trench environments that the war had established as the dominant context for platers. European infantry combat. A 7-round pistol required reloading at precisely the moment when sustained fire mattered most. A 15-round pistol changed the tactical arithmetic of the close-range engagement in ways that the French military's analysis had identified and that the arms industry had not yet found a way to satisfy. A double-stack 9mm magazine was the logical conclusion, and, in the months following the end of the First World War, an arms designer at Fabrique Nationale, Dieudonné Saive, set about designing the magazine before the pistol had even been contemplated. He presented the magazine design to Browning with the list of objectives put forth by the French Ordnance Board, and Browning produced 2 prototype pistols around it, each with a different barrel-locking mechanism. The collaboration between the American designer and the Belgian engineer represented something unusual in the history of firearms development, a case where the magazine, normally the last component considered in a pistol's design, was the first component designed, and the pistol was engineered to accommodate it rather than the reverse. This inverted development process produced a result that conventional pistol design methodology had not achieved, because conventional pistol design methodology had always started from the frame and worked outward to the magazine, accepting whatever capacity the frame dimensions permitted. Saive started from the capacity requirement and worked inward to the frame dimensions the magazine required. The insight was simple. The execution required solving every problem that the conventional sequence had generated and dismissed as unavoidable. The specific engineering problem that Saive had identified and that the French requirement had articulated was not merely about round count. It was about the geometry of the solution. A double-stack magazine, 2 columns of cartridges staggered against each other so that the rounds in one column nest in the spaces between the rounds in the other, holds more cartridges per unit of length than a single-stack magazine. A single-stack 9mm magazine holding 13 rounds would require a grip so tall that it became impractical for average hand sizes. The double-stack geometry achieved the same capacity in a grip of manageable height, but in doing so created a new problem. The grip became wider because 2 columns of cartridges side by side occupy more lateral space than one. Wider grips meant a pistol that was harder to conceal, harder for smaller hands to reach the trigger, and heavier than a single-stack equivalent. Every designer who had attempted a high-capacity pistol before Saive had accepted one of these trade-offs as unavoidable. Saive concluded the trade-off was not unavoidable, it was a function of how the magazine was designed, and a better magazine design could produce the capacity without the width penalty. His solution was the staggered double-column single-feed magazine. The cartridges in a double-stack magazine naturally form a column that is wider than a single stack, but at the top of the magazine, where rounds feed into the chamber, they converge into a single column. Saive engineered the magazine body so that the two columns were staggered as tightly as possible, each round in one column positioned in the space between two rounds in the other column, which minimized the width increase while maximizing the capacity per unit of grip height. The resulting magazine held 13 rounds of 9mm parabellum in a grip that was marginally wider than a single-stack Luger or M1000, 911, but not dramatically, so narrow enough that the pistol remained concealable and manageable for the population of users who would carry it. It sounds like a minor refinement. It was the engineering detail that defined the architecture of every high-capacity service pistol produced in the 90 years since. John Moses Browning was, by 1923, when he received Saive's magazine design, the most productive individual firearms designer in history. The Model 1894 Winchester lever-action rifle, the Browning automatic rifle, the M2 heavy machine gun, the Auto 5 shotgun, the M1911 pistol, 128 patents, covering every category of infantry and crew-served weapon that a modern army required. He was 68 years old when he began working on the prototype that would become the High Power, and he brought to it every lesson from 4 decades of designing firearms that worked under conditions of sustained combat use rather than controlled evaluation. Browning built the first prototype around Saive's magazine in 1923 and filed the patent that year. He built 2 versions, one using a simple blowback design, one using a locked-breech short recoil tilting barrel mechanism derived from the work he had done on the M1911. The blowback prototype was simpler but insufficient for the pressures of the 9mm parabellum cartridge. The locked-breech prototype was selected for development. Browning spent the following 3 years refining the design toward the specific combination of capacity, concealability, and reliability that the French requirement and his own standards demanded. He died of heart failure at his workbench at the FN factory in Herstal on November 26, 1926. He was 71 years old. The pistol that would become the most influential handgun of the 20th century was unfinished. Saive took over the project. The advantage available to him that had not been available to Browning was timing the Colt M1911 patents expired in 1928, freeing the tilting barrel locking mechanism and the simplified takedown system that Browning's own earlier design had established. Saive incorporated these elements, refined the grip geometry, adjusted the trigger mechanism, and finalized the double-stack magazine to the 13-round production standard. In 1935, 9 years after Browning's death, and 14 years after the French requirement had been issued, the pistol was adopted by Belgium as the P35. Grande Puissance, high power. The French, who had commissioned the entire project, declined to adopt it and chose a domestic design instead. The Belgians adopted a weapon designed for another country's requirement and made it their own. The irony would be repeated in various forms throughout the High Power's subsequent history. What Saive had produced in 1935 was, in its fundamental architecture, the template for the modern service pistol. The tilting barrel locked breech mechanism, simpler and more robust than the toggle lock of the Luger and more compact than the alternatives being developed elsewhere, would be adopted by nearly every successful dotages. Military pistol designed after it, including the SIG P226, the CZ-75, and the Glock. The double-stack magazine that fed it, established the capacity standard that the industry would spend the next 9 decades incrementally improving without changing the fundamental principle. 13 rounds in 1935, 15 in the Beretta, 92 in 1976, 17 in the Glock, 17 in 1982. The numbers increased as manufacturing tolerances improved and magazine body designs were refined, but the staggered double-column geometry that Saive engineered into the High Powers magazine is the same geometry in every one of those designs. The Glock 17 magazine and the High Power magazine are the same concept in different manufacturing generations. The Second World War demonstrated what the High Powers architecture was capable of in the harshest possible evaluation environment and simultaneously produced the specific historical irony that any honest account of this weapon is obligated to acknowledge. During World War II, Belgium was occupied by Nazi Germany, and the FN factory was used by the Wehrmacht to build the pistols for their military, under the designation 9mm Pistol 640B. The German paratroopers who jumped into Crete in 1941, the Afrika Korps officers in the Western Desert, the Waffen-SS commanders in France, all carried the High Power, manufactured in the factory of the country they had occupied, from the design of the American and Belgian engineers who had intended it for the armies that would eventually defeat them. FN Herstal continued to build guns for the Allied forces by moving their production line to a John Inglis & Company plant in Canada. Saive escaped from occupied Belgium, carrying the High Powers technical drawings from memory, and reconstructed them in Britain before the Inglis factory in Toronto began production. British commandos, Canadian soldiers, Allied intelligence officers operating in occupied Europe carrying sterile weapons with no serial numbers and no identifying features all carried the High Power that Saive had remembered across the channel, while the same design was being produced in FN's Herstal factory for the army that had overrun it. The pistol that the French had commissioned and declined to adopt armed both sides of the most destructive conflict in human history simultaneously. The institutional verdict of that bilateral adoption is the most specific possible evidence that the High Powers design was not merely adequate, but genuinely superior to the alternatives available no design gets carried by. Adversarial armies in the same conflict through merit alone, and the Wehrmacht's continued use of the FN factory's production after the occupation, rather than substituting their own domestic designs, was itself an acknowledgement that the High Power was the best pistol available to them. The post-war period produced the global adoption that the design's merits deserved. Over 60 nations adopted the High Power as their standard military sidearm in the decades following the Second World War. Australia, Canada, and the United Kingdom were among the early adopters. The British Army designated it the L9A1 and issued it across the full range of its military roles. The SAS used it as their standard sidearm through the Cold War, Northern Ireland, the Falklands, and the Gulf War, a 40-year association between one of the world's most demanding special operations forces and a pistol that the force had evaluated against every alternative available and found superior for their specific requirements. In the Falklands conflict of 1982, both British and Argentine forces carried High Powers Argentina, having adopted the pistol through its own military procurement process, independently of any British association. The bilateral adoption repeated itself at smaller scale, demonstrating again that the design's merits were sufficiently universal to satisfy adversarial procurement communities, evaluating entirely different operational requirements. India adopted it. Indonesia adopted it. Israel adopted it and used it in every conflict, from the War of Independence through the Lebanon campaigns and the various operations that followed. Singapore adopted it for the Singapore Armed Forces. The scale of adoption across 66 national militaries constitutes the most rigorous distributed operational evaluation any pistol has received. These were not sequential adoptions building on each other's experience. They were independent procurement decisions made by military organizations with different operational requirements, different threat environments, different training traditions, and different institutional relationships with the manufacturers supplying their equipment. That they converged on the same pistol across 4 decades of independent evaluation is not a coincidence. It is the market signal of a design whose fundamental architecture was correct for the problem it was solving. The high power passed it everywhere it was applied. The specific reason the high power is overlooked rather than celebrated is the specific moment at which its competitors began to outflank it on the characteristics that the 1980s firearms market prioritized. The Beretta 92 offered a 15-round magazine, a double-action first shot, and a more modern manufacturing process. The SIG P226 offered similar capacity with a reputation for superior reliability in adverse conditions, as this channel covered in the SIG P226 script. The Glock 17, introduced in 1982, offered 17 rounds, a polymer frame, a simple striker-fired mechanism, and a price point that made the high power look expensive by comparison. The United States Army's XM9 trials in 1984 chose the Beretta on package price, and the Army's choice rippled through NATO alliance procurement in ways that accelerated the high power's displacement from inventories that had been loyal to it for decades. Each of those competing designs made its case against the high power on grounds that were real. The Beretta's double-action first shot was a genuine safety advantage for military units that did not invest the training required to safely manage a single-action pistol carried, cocked, and locked. The SIG P226's reputation was earned in the XM9 trials and in SEAL service. The Glock's polymer frame and striker-fired mechanism produced a pistol that was lighter, simpler to maintain, and significantly cheaper to manufacture than the high power's all-steel single-action design. These were not marketing claims. They were documented advantages that the 1980s and 90s military procurement environment valued because the training doctrines and operational environments of that era made them relevant. What none of those analyses addressed was the genealogical relationship between the designs being compared. The Beretta 92's double-stack magazine used the staggered geometry that Saive had engineered into the high power. The SIG P226's tilting barrel locking mechanism was the same mechanism that Saive had finalized from Browning's original locked-breech design. The Glock's double-stack magazine was the same concept in a polymer body. The pistols that outcompeted the high power in the 1980s procurement environment were outcompeting it on the details of an architecture that the high power had established. The foundation was the same. The finishing was different. The credit went to the finishing. The CZ75 is perhaps the most honest acknowledgement of the high power's architectural centrality. Designed by František and Josef Kaučky in Czechoslovakia in 1975, the CZ75 was explicitly derived from the high power's operating mechanism. Its tilting barrel, its double-stack magazine geometry, and its grip dimensions are all recognizably high power in their fundamental architecture. The CZ75 became, in the 1980s and 90s, the pistol that precision-focused shooters who found the Glock's trigger unsatisfactory and the high power's magazine capacity insufficient reached for as a compromise. It was celebrated as an innovative Czech design by a generation of shooters who were unaware that the innovation it represented was primarily the application of high-power architecture to a modern manufacturing context with an updated magazine capacity. The cam-operated unlocking system that the high power established was simpler and more robust than what had come before it, and it was adopted by nearly every successful military pistol designed after it. The SIG P226, the CZ75, and the Glock. The high power established that mechanism. The industry built careers on refining it. The competitive shooting community's engagement with the high power produced some of the most specific documentation of its functional qualities that exists for any 20th century pistol. Practical pistol shooting in IPSC and USPSA formats rewards accuracy, reliability, and reloading speed simultaneously. A combination that exposes weaknesses in both the trigger system and the feeding geometry that controlled range testing does not always surface. The high power's performance in these formats through the 1970s and 1980s was competitive because its feeding reliability, the predictable, consistent presentation of each round from the staggered double-stack magazine into the chamber, was genuinely excellent. The magazine that Saive had engineered in the 1920s fed reliably under rapid-fire conditions that stressed cheaper magazine designs into inconsistent performance. The aftermarket that developed around high-power modifications reflected how seriously the shooting community took the design's potential. Barstow precision-machined replacement barrels that tightened the lockup tolerance and improved accuracy. King's Gun Works and other specialist shops developed improved trigger components that addressed the magazine disconnect problem. Novak's developed low-profile sight cuts specific to the high power's slide dimensions. The infrastructure of aftermarket improvement that developed around the high power was proportional to the depth of the design's user base, a community that understood the pistol's architecture well enough to identify exactly where it fell short of its own potential and exactly what needed to change to close that gap. That community continued to exist and to produce refinements through the 1980s and 90s and into the 2000s, after the Glock had displaced the high power in most professional inventories. Because the design's fundamental qualities were sufficient to sustain a dedicated improvement community, even as the mass market moved elsewhere. The high power's commercial production at FN Herstal ran from 1935 to 2000 and 1883 years of continuous manufacture, a production run that only the M1911 and the Kalashnikov can rival among 20th century firearms designs. The decision to cease production in 2018 was a commercial judgment about market positioning the high power's single-action-only mechanism, all-steel construction, and 13-round magazine had been surpassed by competitors on the specific metrics that the concealed carry and law enforcement markets prioritized. FN resumed production in 2022 after the commercial market demonstrated that demand for the original design persisted despite the availability of objectively more modern alternatives. The buyers who drove that resumption were not buying the high power for its capacity or its trigger system or its weight relative to polymer alternatives. They were buying it for what it felt like: the specific combination of grip geometry, balance, and single-action trigger that the design had been refined to produce between 1923 and 1935, and that subsequent refinements had not improved upon. The high power's trigger is the most consistent criticism leveled at the design, and the criticism deserves honest examination. The disconnector, the component that prevents the pistol from firing unless the trigger is fully released between shots, was designed with a geometry that produced a magazine disconnect safety. The pistol would not fire with the magazine removed. This was a deliberate design decision reflecting the specific safety requirements of the Belgian military specification. The consequence of the magazine disconnect was a trigger pull heavier and less clean than the M1911 single-action trigger that Browning's earlier design had established as the benchmark. High-power owners and gunsmiths spent decades removing the magazine disconnect and lightening the trigger spring to produce a pull weight and quality closer to what the design's single-action architecture was theoretically capable of delivering. The high power with the magazine disconnect removed and the trigger properly tuned is a genuinely excellent single-action trigger. The high power, as issued, with the magazine disconnect installed, is a manageable but imperfect trigger. This distinction explains a significant portion of the gap between the design's mechanical potential and its reputation in a market that valued trigger quality as a primary evaluation criterion. The high power's cultural presence in film and television reflects its operational history rather than its architectural significance. It appears in period films set during the Second World War and in British productions set in the Cold War and Troubles eras because it was there the weapon that British forces actually carried in those periods. It does not appear as the hero weapon in American action cinema of the 1980s because American action cinema of the 1980s was building its visual vocabulary around the Beretta 92 and subsequently the Glock, the weapons that had displaced the high power in American procurement and American cultural shorthand simultaneously. The pistol that had established the architecture those weapons were built from was playing a supporting role in British period dramas, while the design descendants it had enabled were establishing the visual grammar of the American action genre. The high power appeared in The Living Daylights in 1987, in the hands of Timothy Dalton's James Bond, a deliberately chosen detail by the film's armorers, who understood that a British agent operating in the 1980s would plausibly carry the standard British military sidearm. It was one of the last prominent Hollywood appearances the high power made before the Glock's cultural dominance made polymer striker-fired pistols the default shorthand for professional lethality in American cinema. A pistol that had armed British intelligence for 40 years, that had been the issued weapon of the SAS through every significant operation the regiment conducted from Borneo to the Falklands, deserved a larger cultural footprint than its actual screen presence reflects. What it received instead was the quiet acknowledgement of the shooting community that understood its history and the continued commercial demand that brought FN back to production in 2022. It started as a double-stack magazine Dieudonné Saive's staggered column solution to the specific engineering problem of achieving 13 rounds of 9mm in a frame slim enough to carry concealed, produced before the pistol it would feed had been designed, presented to John Browning with a list of French military requirements that the French military would subsequently decline to fund. It survived Browning's death before the design was finished, the French declining the weapon they had commissioned, the Belgian adoption of a pistol designed for another country's requirement, the Nazi occupation that converted the FN factory to Wehrmacht production while Saive reconstructed the technical drawings from memory in Britain, the post-war decades in which it armed 66 national militaries across 4 continents, and the commercial eclipse by the Beretta and the Glock that the design's own architecture made possible. It established the tilting barrel locked-breech mechanism and the double-stack magazine geometry that the SIG P226, the Beretta 92, the CZ75, and the Glock all replicated in the designs that subsequently displaced it. It was manufactured continuously for 83 years. It armed over 60 nations. It served the British SAS for 4 decades. It was retired and resumed production because the market discovered it missed the design that the market had collectively replaced. The Browning high power is not overlooked because it was a minor weapon or a transitional design or a historical curiosity that the modern firearms market has surpassed and filed away as a relic of a different era. It is overlooked because Dieudonné Saive specifically solved, in 1935, the 2 fundamental problems that defined what a modern service pistol needed to be enough capacity to matter, in a frame slim enough to carry, and solved them both so completely that every pistol designed in the 90 years since has been built around the same solution, and the industry that built those pistols found it consistently easier to celebrate the individual refinements than to credit the foundational architecture that the refinements were built upon and refining. If you enjoyed this, hit like, subscribe, and check out the next video right here.